Okay, hi guys. So in this lecture we'll be discussing about E2 reactions. So far till now we have discussed E1 reaction, but now we will be discussing E2 reaction. As the name suggests, it's a biomolecular reaction. Okay, so it is elimination biomolecular. Okay, so first let us see what are the different dehydrohalogenation agents. So different dehydrohalogenation agents, and they be like uh, alcoholic KOH, then we have NaNH2, then we have ETO minus or ETOH, then we have something like this, and this. All these are different dehydrohalogenation agents. So by different dehydrohalogenation I mean um, um, the halogen atom as well as um, uh, water molecule will be formed in this reaction, or simply put, halogen and hydrogen would be removed from the compound and it would form water molecule and X minus, where X is the halogen. Okay, so let's take this example. So suppose I have this compound. So let's say this is a, let's mark this carbon as alpha and these two as beta, and this is also a hydrogen attached. So what happens when we pass alcoholic KOH and heat this compound? So we'll have two set of products. Okay, one will be having CH and another one would be, we would be having something like, okay, so this is what is called Sadzev alkene, and in this we would have something called as Hoffman alkene. Okay, so what is Sadzev alkene? Sadzev alkene is nothing but, if you look at Sadzev alkene, it would be more branched alkene, one point. Second point is more substituted alkene, and another point is it would be more stable. Okay, this is the properties of Sadzev alkene. Okay, so let us now discuss the mechanism of this reaction. So mechanism is something like this, in which we have this compound. This is beta carbon and this is this is alpha carbon, and again we have this as beta carbon. So now what happens is OH minus comes as a nucleophile. We saw that alcoholic KOH we are providing in the reaction as a reagent. It would take this hydrogen. Meanwhile, this carbon would put in its electron from the H bond into forming a double bond between this carbon atom and this carbon atom, and meanwhile this Br would be leaving the carbon. Okay, so let me draw the intermediate it would look something like this, in which we have H here, OH here, again Br here, and finally CH3 here, and you would have something like, this is bond making, this is bond breaking, this is bond making, this is bond breaking. Okay, I'll just mark it. So this is bond formation, this is bond breaking or cleavage, this is again bond formation, and this is bond cleavage or bond breaking. Okay, so all this actually okay, let me show the this is partially negative, this is partially negative. Okay, so all this actually happens in one step in the intermediate. Okay, so this is a, please remember that this is a one step reaction. Okay, all the bond making and bond breaking happens in a single intermediate. Okay, so let's draw the energy graph for this. We would have something like this, in which we have reactant A here and B here. So this is an example of endothermic process. This is an endothermic reaction. Obviously we have reaction coordinate here and we have energy profile here. Okay, so I have also mentioned in previous lectures that whenever there is a sigma bond breaking and a pi bond is formed, there it is a endothermic process. Delta H is positive, and whenever from sigma bond we have pi bond formation, delta H would be negative. Okay, this is endothermic and this is exothermic. Okay, so with this we conclude this lecture. In the next lecture we'll be seeing more analysis and characteristic of this reaction. Till then, good luck and goodbye.